Hi everyone. The name of this presentation is Demystifying Next Generation 911. NextGen is one of the hottest topics of conversation right now in the North Carolina GIS community. Hopefully I can offer some basic insight into 911 systems and why this project is so vital to public safety. Our objectives will be to learn a brief history of 911, define the terms ANI, ALLI, and MSAG, and discuss their importance, discuss GIS data required for NextGen 911, how to start producing I3 compliant GIS data, and finally we will discuss what happens after a PSAP becomes I3 compliant. First of all, let's look at a brief history of 911. In the good old days of Mayberry, citizens in need would pick up the phone, which was still wired to the wall. Sarah, the operator, would answer the call at the switchboard. Sarah would patch the call to Sheriff Taylor's office. If the caller was lucky, Sarah wouldn't have to interrupt Barney's conversation with Juanita at the diner. Things would change in a few more years. In 1968, 911 was introduced. It is now referred to as Basic 911. A caller would get an operator and give the operator their address. To add to the difficulty, not all streets were named back then. No caller information was displayed to the operator. The operator would use the caller's area code to route the call to the correct agency. In 1999 came Enhanced 911, or E911 as most of us know it. E911 is based on copper landlines, which were still the standard in 1999. The enhanced part comes from the system being enhanced to handle cellular phone traffic. Calls are routed to a public safety answering point, or PSAP, with the caller's information displayed for the dispatcher. Calls are routed using tabular data. No GIS is used in the process. The ALLI database is used to reference the address of the caller. Calls can only be routed within the system where the call originates. If a caller in County A has Frontier as a carrier, and a 911 call needs to be transferred to County B, who has CenturyLink as a carrier, only the voice part of the call can be transferred. No other information will be passed along. The significant developments with E911 were Phase 2 wireless and GIS mapping. A cell phone caller's location is triangulated using cell towers and is routed to the PSAP by the wireless carrier. FCC standard says that the caller must be triangulated to within 50 to 300 meters of their actual location. GIS mapping is an enhancement in most CAD software, but not a driving force in how the call is routed. This brings us to Next Generation 911. NextGen has been brought about in no small part to the death of copper-lined house phones and the rise of cell phones and digital calling technology. In NextGen, PSAPs are based in digital and IP calling technologies. NextGen can accommodate digital information feeding in from the public. Content can include text messages, video chats, and photos. NextGen is geared toward accommodating cell phones, VoIP phones, and other internet-based calling technology, along with being able to handle calls from copper landlines. Mobile devices will be able to transmit their location, which is much more accurate than being triangulated from cell towers. Calls are routed using GIS, where PSAPs and responders are determined with a GIS spatial query. Calls can be transferred to any PSAP in the U.S. that is on the ESINet. This becomes very important if a caller is routed to Allegheny County, for instance, and the call needs to be transferred across the state line to a call center in Virginia. So what is an alley? We have all heard that term buzzing around now for months. In a nutshell, it's a lookup table of phone company customers and their physical addresses. ALLI stands for Automatic Location Identification. It is a table of locational detail that is tied to a phone number. It is used as a lookup table for the automatic number identification, or ANI as it is commonly known, transmitted with a voice call. This is essentially a data join that automatically sends the caller's address information to a PSAP. The ALLI is used in conjunction with the MSAG to route calls to the correct PSAP. The ALLI is maintained by the PSAP's local phone carrier or a subcontractor of the carrier. One example of a subcontractor would be Intrado. Let's talk about the MSAG. An MSAG is a Master Street Address Guide. It is defined by NinaWiki as a database of street names and house number ranges within their associated communities, defining emergency service zones and their associated emergency service numbers to enable proper routing of 911 calls. The MSAG is essentially a spreadsheet with road names, ESNs, and address ranges that tells the phone company's router which PSAP gets the call. According to Nina, MSAG addresses must be absolute and unique. Elements of the street name need to be uniform. House numbers should never repeat. Another thing to bear in mind is that the road names should never repeat within a community, thus the need for community designations in the road center lines. The biggest buzzword that I have personally heard for a couple of years is ESINet. ESINet stands for Emergency Services IP Network. It is basically an emergency services cloud and can host many applications and core services, including NextGen 911 services. I will use the ESINet in the context of Next Generation 911 for this presentation and not go down the rabbit hole of everything this thing really does. The ESINet serves two core functions using GIS data. First, it leverages GIS and call routing using a spatial query to determine the PSAP that will receive a 911 call. GIS overlays also determine which emergency agencies respond to the call. It also uses GIS to geocode and validate addresses of landline calls so that they can be routed to the correct PSAP. AT&T is North Carolina's ESINet provider, with GeoComm acting in the capacity of GIS quality control middleman between AT&T and local PSAPs. DataHub is GeoComm's data transformer and automated GIS quality control platform. It provides a summarized quality control report along with a file geodatabase that shows you the locations of all errors needing TLC. In the attributes, you basically have all of the information you need to make the necessary corrections to your data. This is an illustration of how the ESINet routes calls. Forgive the crudeness of the illustration because the Highland Mapping Art Department really doesn't have that much of a budget. To have calls routed through the ESINet, a PSAP must be I3 compliant. I3 is the functional and interface standard for NextGen 911. All of your GIS data must be free of critical errors. I will run through those with you in upcoming slides. Your alley also has to have a 98% geocode with your road center lines using street name elements and community fields. Why do we need at least a 98% match of the alley to the GIS center lines? To make sure that all of the alley addresses are accounted for within the address ranges of the road center lines. And none of this is really too much to ask, considering that our GIS data is becoming a life-saving tool. What data is actually required by AT&T? We can start with the GIS data. At a minimum, you need to submit a provisioning boundary, also called authoritative boundary, a PSAP boundary, road center lines, address points, and emergency response boundaries. You will also need to submit a copy of your alley. The alley needs to contain a house number, a road name and all of its related elements, and community. The most important GIS layer to your submission is the provisioning boundary. Simply defined, a provisioning boundary is the area in which you are responsible for the GIS data. The outer boundaries of the PSAP and emergency services boundary must all be coincident with this polygon. Think of the provisioning boundary as a cookie cutter, and everything else you submit is cut into the shape of that cookie cutter. It is recommended that you use the NCAUG Survey North Carolina State and County boundary polygons projected in North Carolina State Plane Nat 83 feet as your provisioning boundary, making adjustments as needed with your neighbors. Also, please keep in mind that this boundary has nothing to do with tax situs. This is all about emergency response. A PSAP boundary is the area in which your call center takes 911 calls. More than one PSAP can be within a provisioning boundary. A good example of this would be a county PSAP taking calls from rural areas and a city PSAP taking calls from the city, while the county maintains all of the GIS data. A PSAP can also be split by provisioning boundaries, although this is extremely rare. The outer boundary of the PSAP feature class must be coincident with the provisioning boundary. There again, it's cut out with a cookie cutter. Emergency service boundaries are your primary emergency response areas. At a minimum, fire, law, and medical boundaries are required. If you have an ESN feature class, that is okay as well. All inner boundaries must be coincident with no gaps or overlaps. The outer boundary has to be coincident with the provisioning boundary polygon. It's starting to sound like a broken record, isn't it? Any area of mutual aid that falls outside of the provisioning boundary has to be split at the provisioning boundary. The area outside of the provisioning boundary needs to be given an exception code. With GeoComm, that code will be 999. Let's take a look at some examples of boundaries and discuss the cookie cutter effect of the provisioning boundary. I want to thank Misty Tabor, Communications Director at Swain County, North Carolina, for letting me use their data as an example. Swain is a small western county, but they contain pretty much every odd example of boundaries that I can throw at you. First off, this is their provisioning boundary. As we have already discussed, the provisioning boundary is the cookie cutter for all other data sets. To begin our odd journey into Swain's data, their provisioning boundary isn't even their entire recognized county boundary. The northeastern part of the county is National Park. The GIS data and PSAP are within the eastern band of the Cherokee's provisioning boundary. This boundary being for emergency services, we remove the part of the county maintained by the eastern band, but I digress. This will be our starting point. The first cookie that gets cut is the PSAP boundary. Swain's provisioning boundary contains 4 separate PSAPs. The PSAP outer boundary is completely coincident with the provisioning boundary. The PSAP boundaries for Macon County, Graham County, and the eastern band of the Cherokee are all cropped to Swain's provisioning boundary. Although I intentionally didn't label them, the individual PSAPs within the provisioning boundary have their own service URIs that route calls to the appropriate PSAP, and none of them carry an exception code. They all carry Swain's discrepancy agency ID since they are within Swain's provisioning boundary. The same cookie cutter concept applies to the EMS boundaries. The outer boundary is completely coincident with the provisioning boundary. Although EMS services are coming in from out of county, those service areas are split at the provisioning boundary. Law boundaries follow the same example. Notice that 3 separate sheriff departments and a sovereign nation's police department all respond within one county. On to what is usually the most controversial set of boundaries: fire. Fortunately for Swain, there's peace in the valley with their departments. Again, 4 out-of-county departments are primary responders within Swain's provisioning boundary, but their boundaries are split and coincident with the provisioning boundary. A note on all out-of-county responders: it doesn't matter that a responder is associated with another county. The response area within Swain's provisioning boundary, for example, will carry Swain's discrepancy agency ID. Let's talk about critical errors. As you know from all of our workshops, GIS feature classes have to be free of critical errors in order to be I3 compliant. Road centerlines can have no overlapping segments. Segments not covered by the provisioning boundary are also a critical error. You can avoid this by breaking centerline segments at the provisioning boundary, placing a vertex on the provisioning boundary itself at the break, and coding the new segment outside of the provisioning boundary with an exception code. Again, with GeoComm, that code will be 999. Also, be sure to adjust your address ranges on either side of the provisioning boundaries after you split the road segment. Snapped intersections are not a critical error, but I highly recommend fixing those. If emergency traffic is ever routed using GIS centerlines, you'll be way ahead of the game. This example shows a road broken at the provisioning boundary. The red segment is in a different county and carries a 999 exception code. Where the color changes at the provisioning boundary, the road segment is split and the address range is treated like a road intersection. Oddly enough, 20 miles southeast, the road crosses back into the provisioning boundary. The oddities of Swain County. Missing mandatory attributes are also critical errors. This is a list of mandatory fields in general terms. Make sure that you have these fields in your data for submission and that the field has something in it for every feature. Let's go through them. First of all is a discrepancy agency ID. This is your agency and your PSAP's unique identifier, and you need to know what that is, and it needs to be in every feature in your data. Also, they want date updated. The road centerline NINA globally unique ID is the one that puzzles a lot of people. And that's just essentially some randomly generated number plus your discrepancy agency ID in the format that's on the screen. Now, you can use object ID for the random number if you would like, and that works because The number is only going to be good for one DataHub submission. After that, when you resubmit again to correct errors, that number can reset and it doesn't hurt a thing. In Centerlines, you want address ranges. You want parity. You want street name, at least. All of the elements are good, but you want street name at least. Country, state, and county. And the big one is incorporated municipality. You want that populated. If you have roads that are outside of a municipal boundary on your maps, that road segment needs to be marked unincorporated. And finally, you want MSAG community. MSAG community helps with the alley geocode, and because of that, it is a mandatory field. So make sure that you have that in your data and that it matches the alley and the MSAG. Other attribute errors include parity and address range overlaps. If you address odd addresses on the left side of the road and indicate that the parity is even on that side of the road, that is a critical error. GeoComm's toolkit, available from NCDIT's NextGen landing page, includes a Python script that will calculate parity for you. Address range overlaps are also a critical error. In the example below, the first segment of Davis Branch Road has a top range of 602. The second segment picks up at 602. This would trigger a range overlap error. Range gaps are acceptable to accommodate situations such as block addressing. Just be certain that if you do have gaps in your ranges, that all of your alley addresses fall within ranges present on the center lines. Address point critical errors are a little different. The biggest issue with address points that I have seen are duplicate addresses. Duplicate address points are points with the same physical address and no unit designation. If you have an address point on a farmhouse and put the same address point on a field across the road to aid emergency response, assign the duplicate address in the field an exception code. Addresses that fall outside of the provisioning boundary are a critical error. Make sure that they are assigned an exception code. Missing mandatory fields are also critical errors. Refer to the previous mandatory field list on the Centerlines and GeoComm documentation for guidance. Next, I will pass along some practical tips for preparing legacy data for NextGen migration. First of all, get a copy of your alley. Geocode it using a locator built on individual street name elements such as predirection, name, street type, and post direction. You will also use a community as a criterion. Set the match criteria to 99% and do not count the ties as a match. This will give you a good idea of where you will stand with an initial DataHub alley match. This is a locator setup that I commonly use. The type parameters ensure that the results will mirror DataHub's results within a percent or two. Next, make sure your street naming is consistent and standardized naming across center lines, address points, alley, and MSAG. If you don't store MSAG communities and incorporated municipalities in your legacy data, I highly recommend adding fields for them in your center lines and address points. Make sure the communities match the alley and the MSAG. It has been helpful for me to store exception codes in the center lines and address points that I'm editing. These schema tweaks will save you a lot of work once you start to migrate into a NextGen data model. Tying in with standardizing street names, make sure that you give the person who updates your alley a list of any changes that need to be made to your road naming. It takes a burden off of them if they don't have to figure out why they can't get a 98% match with the data they maintain. Clean your geometry. Fix overlaps and gaps in your polygon feature classes and make them coincident with your provisioning boundary. Make sure that you break center lines at the provisioning boundary. Thinking into the future, invest the time to make sure that your road intersections are broken and snapped and that the address ranges are correct at the intersection. Talk to your neighbors. Eventually, your boundaries will need to be coincident with surrounding counties. Start that conversation ASAP. Finally, openly communicate with your addressing department, communications director, and emergency officials. This will pay massive dividends as projects roll along. No one knows better than they where boundaries lie, roads end, etc., etc. So what happens after you become I3 compliant? The county's work has just begun. Once you meet the I3 standard, you have to maintain it. Plan a workflow around the NextGen data model. If possible, adopt the model outright and add fields proprietary to in-house applications as needed. Maintenance will be much easier in the long run. If you can't adopt the model, it is possible to automate exports into the NextGen model from legacy data. Although this method works in the present, I don't recommend exports as a long-term solution. Once AT&T approves you as I3 and you go live, you will have to keep your data updated with them via DataHub. GeoComm, using DataHub, will act as a quality control agent for AT&T. If your update doesn't pass muster on DataHub, it will be held by GeoComm until the errors have been corrected. There are many great resources out there for NextGen 911, but these are the ones I use daily. First of all, NCDIT has a great landing page for the North Carolina NextGen project. It contains GeoComm documentation and tools, I3 status state, and various other tidbits of good information. The NC GeoComm team is very responsive and helpful, especially with DataHub questions. Last but not least, Brandon Moore is North Carolina's local county support person. He is very down-to-earth to talk to and is extremely helpful with data compliance. I would also like to thank him for his fact-checking and tidbits of inside information for this presentation. Finally, if you have any questions, feel free to reach out to me. This is my contact information. Thank you for the opportunity to talk to you, and good luck with your projects.